Good evening, my dear viewers. My name is Chwenge Victor, and today I want to take you through the fundamentals of artificial intelligence while focusing on my model, which is an injury prediction model in what? In football. Yeah, so now football might look like it's just about speed, tactics, and also talent, but I don't know if I ever given it much thought about the impact an injury can have on a player's performance or even a team's performance. Yeah. So that's why I started my project on this model, which focuses on predicting the likelihood of those injuries. Yeah. So straight away I'll go to my challenge and the AI solution. Yeah, so in football we have injuries and my model is mainly going to focus on those football related injuries. We have hamstrings, ankle sprains, ACL tears and even those muscle cramps. Yeah. And these are like a major risk to a team's performance because when a player is injured, then the team doesn't perform very well. So traditionally, preventing these injuries heavily relied on medical expertise, careful scheduling of training and matches, and also monitoring the workload of the players themselves. But if I'm being honest, or if we're being honest, that is all human judgment. And we also know we are humans. So such judgment can only go so far. Yeah, that is why AI is people create these search models like mine to devote that building of artifacts that can display that intelligent behavior to make us achieve such goals like with ease. So this model of mine can analyze a lot of data points, for example, the biomarkers, the training history of the players, and some environmental factors to give the coaches like insights. Otherwise, with their human judgment, they can miss those subtle details. So our goal is simple. We want to create a decision support tool that will help coaches and the medical staff make smarter data-driven decisions. For example, our model alerts coaches when a player is at high risk of getting an injury, and this can directly reduce the match day injuries. Yeah. So to start, let us first have a preview of the trends and history, not in AI. To understand where we are today, if we look back at the history of AI, it all began with those small concepts, the ideas that were there some time back, like Leonardo da Vinci's design for the humanoid robot. Yeah, and early AI research, for example, with the figures like Alan Turing that started with symbolic systems, they focused on logic and manipulating that logic using the rules being provided. Yeah, but we can see that this shifted to those statistical approaches where guys were using those probability. Then right now we have machine learning. Yeah, where we have algorithms that learn from the data provided. And today, as we can see, deep learning is a major trend. It uses neural networks to recognize those complex patterns behind the events we are trying to achieve. And this evolution of AI, it is also defined by those concepts like weak and strong AI. And currently we are focused on weak AI. Yeah. Building machines that act intelligently for those specific tasks they're designed for. Yeah, and I think strong AI right now is still like a dream. We're just dreaming of building those conscious machines that can think like us. And I think it's still out of reach for us, for the meantime at least. And my project fits within this trend. It's a practical example of using machine learning to predict injuries from historical player data. Yeah. So how does this trend link up with my project? In the past, most teams and those sports people they relied on simple rules. Yeah, or medical those heuristic patterns. And in this modern approach, we want like to develop such models like mine. And my project embodies those predictive learning models that analyze the multiple data given to them simultaneously because they can analyze them at a go. And AI can now integrate data from wearables. We have my model and we have the players wearing those maybe watches. Yeah, it can look at data from those watches and also the historical performance of the players themselves. So my model, for instance, It uses factors like cortisol levels, fatigue scores, and past injuries to generate that risk score, like the percentage at which it's confident that a player will what? Will sustain an injury. And this is the fundamental shift from relying on the intuition that those olden people, which is not some time back, the intuition they were relying on and some little bit of guesswork, to this more systematic data driven approach that we can try and see that it may be more reliable than that than the human judgment. Then we have problem solving in artificial intelligence. And we all know at its core, like AI is that guy you trust, a real problem solver. So to build an effective AI system for any problem, you must first define that problem precisely, then you analyze it, and also represent the necessary knowledge for that problem. And from our knowledge from the fundamentals of artificial intelligence, we know that each and every problem has three key components. It has the state, the operators, and finally the goal which you're trying to achieve. For my project, we can see that the state is the player's current health data. The operators are the algorithms that are going to analyze that data. And the goal, which is what you want, predicting the player's likelihood to sustain an injury. So to make this process efficient, we shall use heuristic functions, and these are just smart shortcuts that help the system find that solution without going through that long, exhaustive search. And in this case, it is slightly similar to how a doctor can use their medical experience to focus on those few key symptoms. Yeah. So now for us, shall just be doing it in an automated way using this model. Uh, so if we go to linking this problem search my with my project, we can see that the initial state, we have the players, their biometrics, their current biometrics, which are we can obtain from after, like during training or after training. Yeah, so that is the player's state. That's the initial state, which is the player's how the player is. Then the search projects, the search process in our AI model is analyzing the complex data because we're going to be giving it the biomarkers. We're going to be giving it the player's historical data. Then the heuristic, we use it to focus on what matters the most and those like mattering variables like the fatigue and stress hormones. Yeah. Then the goal that is very clear, we are trying to predict the likelihood of the injury itself. So if you have such analysis, it allows our system to cut through that noise that the data is being given because the data doesn't have context. Yeah. So such a system with its structured analysis will help us like to reduce that kind of hectic activity. Yeah, so we shall be having those fast and effective answers or solutions. Uh, how do we solve problems by searching? So AI can solve problems using either uninformed search strategies like the depth first, the breadth first, or even more efficiently using informed searches. Yeah, like the ESTAR algorithm. So informed search finds solutions faster because as it is informed search, it uses knowledge while it's operating. So that guides its direction. Wherever it's going, it knows it has that little trace of knowledge in it. Then maybe also talking about another concept, which is very not very but important, the game theory, which is used for problems with competing agents. So while this project, my model, though it isn't a game, we can use similar principles from concepts like the and or graphs to break down like our complex problem, in this case, which is predicting the likelihood of a player getting injured. So we get that problem, then we divide it into smaller manageable tasks, and this allows us to find the most probable injury type and its root causes if we want to go deeper into the problem. So we can also have search optimization. Then let's want to talk about a key part of my model, which is clustering. So think of it in this way. We have very many players. A team can have very many players. So instead of analyzing every player, player one, player two, player three, we can get those players, we group those players into players having similar biomarker patterns, maybe those with similar fatigue or stress profiles. Yeah, so what does this help us? This helps us reduce that complexity in the search. If you are searching for a pattern, it allows our system to achieve faster and more accurate predictions because we have that clustering where some patterns are almost together. Yeah, so the coaches can get an accurate alert about a cluster of what? Those high risk players. And this allows to intervene before the injury happens. So we go to knowledge representation. What is knowledge representation? Knowledge representation simply is what turns that raw data we have into something that is actually going to help us. And for maybe in this project, you can see that data alone is just, it's there, it's important, but then give us that extra context. So it only becomes very useful when it's structured with the context we need. So we have maybe like symbolic AI that uses symbols and the rules given to it, such as that if we want to know, if we want to predict the likelihood of an injury, we know that if cortisol is high and fatigue is high, then injury risk is going to be what? High. Yeah. So in contrast, we can see the connectionist AI, which is just based on those many networks, neural networks, that help us recognize those patterns, or that help the model recognize those patterns automatically. It sees this pattern and it knows this pattern, not as it knows where it has learned it before. But in either case, we remain with the same goal, which is achieving our goal. Yeah, through those intelligent decisions being made by the model. So how do I have this representation in action? So my project uses first order logic, and this is done by having those historical injuries as the rules, our logical rules. And this form of symbolic representation, it allows the model to not just look at this data as numbers, but it's going to help the model understand the patterns behind those numbers. So we give it the numbers, then it tries to come up with how it will understand the pattern behind those numbers. For example, my model can learn that a player who has had two hamstrings, maybe in the past times, is more susceptible to incur another hamstring injury. Yeah, because it's also seeing that basing on the biomarkers, this player sustained these injuries because of this. So since it's tracing that pattern again, then it can flag that player as what? As a player who has a high risk of getting that specific injury again. So if I talk about inference in first order logic, inference simply means getting new conclusions from those existing data we have. Yeah, and AI systems are designed to ensure that this reasoning, both sound, I can try to relate it to that maybe the system never draws like false conclusion from true premises like in the past. And by complete like reasoning, I can maybe relate it like the model can just eventually derive any true conclusion. Yeah. So my model applies this principle to player data itself. Yeah. For example, if the model knows that a player is fatigued basing on our biomarkers, if that player is fatigued or dehydrated, it can infer a high chance of that specific injury that is related to the player being fatigued or dehydrated, which in most cases are muscle cramps and what? And straining the hamstrings. Yeah, so this extends the doctor's reasoning power because even the doctor can start to know that, yeah, this machine has seen this, so it can, whatever is giving me is accurate to this point because it has happened before. So, how I use inference in my project? In practice, A classifier in my model might output a simple fact like a player A has high fatigue levels. So the inference layer then combines this fact because it's just a stated fact with other data points, which in this case we can have from the biomarkers, we can trace the hydration levels of that player, that specific player that has the high fatigue, to predict a specific likely strain. This ability to connect those multiple signals and come up with new accurate conclusions is where AI like real stands out and produces that gap between the human judgment and itself, showing that gap because it will be very difficult for a human to judge that. So I want to talk about reasoning under uncertainty. So in sports we have those unpredictable things. Yeah, and this going we can talk about injuries that are hard to predict by humans. So AI must be able, like capable to reason under any uncertainty. It's not Bamboo very confident. I want to put it like that. So we can use maybe the probability theory in our model to handle this. For example, we have the Bayesian reasoning. And for this case, the Bayesian reasoning, it allows the model to update its own beliefs that it's coming up with. As new evidence is coming in, so as with time it keeps on improving. Then we also have the utility theory, which allows the model to weigh the desirability of different outcomes. So instead of giving a simple yes or no, our AI can just say there is an 80% chance, which in this case is what we want. So to proceed, my model predictions are dynamic, like they be changing. A player's condition can change. So even if a player's condition is changing, which means even what, the prediction can also change. An example, if a player improves their hydration, then obviously their what injury risk is going to reduce. Yeah. So this flexibility can allow coaches to make those real-time adjustments. The player improves their hydration, even the that prediction changes. Then I'll talk about planning. Mm, Planning is just about determining that most efficient way, like a sequence of actions that our model has to achieve that desired outcome, has to follow to achieve that desired outcome. So that planning, it allows an AI to be like proactive, like it's actually participating other than just reacting to what we are giving it. And for injury prevention, the plan might be maybe a rest day, adjusting diet, or therapy on a given day, or even maybe a lighter training session to reduce what? Reduce the workload. So linking to my project, the planning, my project has that cycle of detecting, predicting, advising, then act. And those are all done by, you can see the first part is being done by the model, then the last part is acting, and the rest is being done by what? By the people in charge. So first we detect the risk, then the model, after predicting the risk, we advise, then the coaches can act. Yeah, so this ensures that the interventions are done at the right moment. Then, if we talk about decision making, we can see that those decisions are rarely simple. Coaches must balance that performance of players. Yeah, and then I can help in making these choices, maybe by using complex choices like we have the Markov decision processes that use those complex choices to what? To balance those predictions. Talking about decision making, my model intelligently can weigh those potential injury risks against the performance, and this helps us to help those coaches target the tough calls. Like they need to know when to do this, how and how it will impact the team. Should the player rest? Should they just play fewer minutes? Should they participate fully? Yeah, and that is what I actually mean when I talk about the data-driven recommendation. It's coming, we are deriving it from somewhere. Yeah, so that tool, my model, is helping us in that decision making. Then machine learning, which is the core. So machine learning is the core of almost modern AI and programs that can automatically learn from experience. There are mainly two types, which is supervised and unsupervised. So we're running out of time. So supervised learning, we can just use this to classify a player's injury risk, because supervised, the model is learning from labeled data. We have our data, we label it, the machine sees the labels, then it tries to learn from those labels after like given like, I want to call it like a test data set. Then unsupervised learning, then the machine is just learning, it's learning, tracing patterns without using any labels given to it. Yeah, then we can also have reinforced learning, and this just enables the model to adapt, like it learns, makes some refinements, learns, makes more refinements, and this is through that try and error mechanism. So the key takeaway is just that we have weak AI, and looking forward to the future of AI, we have seen that we have the strong AI that we think it may come up, them that such AI tools should just be like used as support tools, not using them to rely on them to replace like the human expertise. Yeah, thank you very much for listening to me. May God bless you.